Today we are going to learn about mastering Bayes' theorem, real-world applications. We will explore how to apply Bayes' theorem to make informed decisions and enhance your data analysis skills.
Welcome to our session on mastering Bayes' theorem. Bayes' theorem is a powerful statistical tool that allows us to update our beliefs when new evidence is presented. In today's world, where data-driven decision-making is key, understanding Bayes' theorem is more important than ever. This theorem is essential in various fields, from machine learning to finance. In this video, we'll cover the basics of Bayes' theorem, delve into its real-world applications, and explore how you can leverage this tool to make more informed decisions. By the end of our session, you'll have a solid understanding of this critical concept and will be able to apply it to enhance your data analysis skills.
Let's start by understanding the formula of Bayes' theorem. At its core, Bayes' theorem provides a mathematical framework for updating the probability of a hypothesis based on new evidence. The theorem is expressed as PA vertical bar B equals PB vertical bar A PA, PB. Here, PA vertical bar B is the posterior probability, which represents the updated probability of the hypothesis A given the evidence B. PB vertical bar A is the likelihood, indicating how probable the evidence is assuming the hypothesis is true. PA is the prior probability, our initial belief about the hypothesis before seeing the evidence. Finally, PB is the total probability of the evidence. By breaking down the formula, we can see how each component contributes to the final outcome. This understanding forms the foundation for applying Bayes' theorem in real-world scenarios.
In this block, we'll delve deeper into the components of Bayes' theorem: prior, likelihood, and posterior probabilities. The prior probability, PA, represents our initial belief about the hypothesis before any new evidence is considered. It's crucial to establish a reasonable prior to make accurate predictions. The likelihood, PB vertical bar A, tells us how probable the evidence is under the assumption that our hypothesis is correct. It's a measure of the compatibility between the evidence and the hypothesis. The posterior probability, PA vertical bar B, is the updated probability after considering the new evidence. It reflects our revised belief about the hypothesis. Bayes' theorem essentially provides a structured way to update our beliefs in light of new evidence. This process of updating is fundamental to data-driven decision-making and helps us make more informed judgments in uncertain situations. Bayes' theorem has significant applications in medical diagnosis, where accurate interpretation of test results is crucial. In healthcare, tests often yield results that need careful probabilistic interpretation. For instance, consider a test for a rare disease. Even if the test is highly accurate, there's a chance of false positives due to the rarity of the condition. Bayes' theorem helps us calculate the probability that a person actually has the disease given a positive test result. By considering the prior probability of the disease, its prevalence in the population, and the likelihood of the test result, we can update the probability of the disease being present. This approach reduces the risk of misdiagnosis and leads to better healthcare outcomes. Understanding Bayes' theorem empowers healthcare professionals to make more informed decisions, ultimately improving patient care.
Spam filtering is another practical application of Bayes' theorem. Email providers use Bayesian spam filters to distinguish between legitimate emails and spam. These filters analyze the content of emails and assign probabilities to different words based on their likelihood of appearing in spam emails. By considering the prior probability of spam and the likelihood of specific words or phrases, the filter calculates the posterior probability of an email being spam. Over time, as more emails are classified, the system updates its probabilities, becoming more accurate in distinguishing spam from legitimate messages. This continuous learning process is a prime example of how Bayes' theorem can adapt and improve decision-making in real-world applications. For users, this means fewer unwanted emails in their inboxes and a more efficient email experience. Bayes' theorem is a valuable tool in finance, particularly in predicting market trends. In this case study, we'll explore how Bayesian analysis can be used to make informed investment decisions. Financial markets are dynamic, influenced by various unpredictable factors. By applying Bayes' theorem, analysts can evaluate current market conditions and incorporate new data to update their predictions. For example, consider predicting stock prices. Analysts can use prior probabilities based on historical data and update these with new information, such as economic indicators or company earnings reports. This process allows for real-time adjustments to investment strategies based on evolving evidence. By continuously refining their models, financial analysts can make more precise predictions, reduce risks, and optimize investment portfolios. This case study highlights the power of Bayes' theorem in navigating complex financial landscapes. While Bayes' theorem is a powerful tool, there are common misconceptions and pitfalls to be aware of. One common mistake is misinterpreting the results. It's crucial to understand that Bayes' theorem provides probabilities, not certainties. Over-reliance on initial prior probabilities can lead to skewed results if not updated with new evidence. Similarly, ignoring the role of likelihood and adjusting beliefs can result in inaccurate conclusions. In real-world applications, data quality and relevance are critical factors that can affect the accuracy of Bayesian analysis. To avoid these pitfalls, it's important to continuously update priors with new evidence, carefully interpret the results, and ensure that the data used is reliable and relevant to the context. By being aware of these common errors, you can maximize the effectiveness of Bayes' theorem in your decision-making processes.
To effectively apply Bayes' theorem, various tools and software solutions are available to assist in Bayesian analysis. Popular platforms like R, Python, and MATLAB offer libraries and packages specifically designed for Bayesian statistics. These tools automate complex calculations, making it easier to apply Bayes' theorem in real-world scenarios. For instance, Python's PyM-C3 and R's Bayes factor are widely used for Bayesian modeling and inference. These tools allow users to integrate Bayesian analysis into their workflows, enhancing decision-making efficiency. By leveraging software solutions, you can handle large datasets, perform simulations, and visualize results, all while reducing the risk of manual errors. Automating Bayesian analysis not only saves time but also ensures more accurate and reliable outcomes, empowering you to make data-driven decisions with confidence.
Now that we've covered the theoretical aspects of Bayes' theorem, it's time to put your knowledge into practice. In this block, we'll explore exercises designed to help you apply Bayes' theorem to solve real-world probability problems. These practice problems will present scenarios where Bayesian analysis is crucial, such as medical testing, market predictions, and spam filtering. We'll walk through step-by-step solutions, demonstrating how to calculate prior, likelihood, and posterior probabilities. By engaging in these exercises, you'll improve your problem-solving skills and gain a deeper understanding of Bayes' theorem. Practicing with real-world examples will enhance your ability to apply Bayesian analysis in various contexts, ultimately making you more proficient in data-driven decision-making.
As we conclude our session on mastering Bayes' theorem, let's recap the key concepts we've covered. We've explored the formula and components of Bayes' theorem, delved into its real-world applications, and discussed how it empowers you to make informed decisions. Bayesian thinking is not just a statistical tool, it's a mindset that encourages continuous learning and adaptation in the face of new evidence. By applying Bayes' theorem in various contexts, from healthcare to finance, you can enhance your analytical skills and make more accurate predictions. Remember, mastering Bayes' theorem is an ongoing journey. With practice and application, you'll become adept at using this powerful tool to navigate uncertainty and make data-driven decisions with confidence. Thank you for joining us, and we look forward to seeing you apply these insights in your endeavors.